Okay, what we're really interested in is using polar coordinates in order to simplify certain problems. When you look at problems in polar coordinates rather than Cartesian coordinates, they get simpler. Some problems do anyway. So normally in Cartesian coordinates, our XY system, we have equations that we solve. The set of pairs XY that solve the equation will be on the graph. Okay. Now it turns out that some graphs get way simpler equations in one coordinate system or the other. Okay, so for instance, we might want to write equations in polar coordinates that satisfy a polar equation rather than a Cartesian equation and describe the curve that way. So for instance, here's a polar curve. So instead of saying a Cartesian curve, because we're using polar coordinates, and the equation that describes it is not a Cartesian equation, it's a polar equation. Okay, so this polar equation, r equals 1, is we're looking for the set of all r comma theta that solve r is equal to 1. So what are they? Well, any theta will do, because r has to be equal to 1, and any theta will do. So actually, this describes this curve. Here is r equals 1 there, and any theta with r equals 1 describes a circle of radius 1, the unit circle. So actually, if you convert that into Cartesian coordinates, so the Cartesian curve given by the Cartesian equation, x squared plus y squared equals 1. That's the formula for the unit circle, after all, gives the same curve. Okay, so notice, in polar coordinates, the equation for a circle is dead simple. It's like the simplest possible equation. And over in Cartesian coordinates, it's, it's a little bit more clunky to work with. Similar situation exists with theta values. So for instance, let's think about a polar curve now given by a polar equation, theta equals pi over 6. Okay, so in the same way, we're looking at all r theta that solve the equation, theta equals pi over 6. And in this case, any r will work. Yeah. So this actually means to take a look at moving pi over 6 away. So that would be this angle right here, pi over 6. And any r will work. So that means walk forward any distance away from the origin in that direction, positive values of r. Put that over here. R is actually greater than 0 over here. And we can also walk backwards from the origin in the direction pi over 6, because negative values of r also work. So we get all these as well. And those would go with r values being less than 0 over on that side. Okay, so the Cartesian equation now will be the equation for this line. So again, it's going to be a little bit more difficult to see, right? We're going to want a slope, and well, the y-intercept at least is easy, right? So the Cartesian equation will be y equals mx, where m is the slope. Okay, and how do we find the slope of something with that theta? Well, think about our definition of polar coordinates again. We would have an x value going away in this direction and a y value going up right there. Right, that's how you translate between polar and Cartesian coordinates. And so the slope of that line is actually y over x. M would be equal to y over x. And you know a trig function that calculates y over x? Sure, that's the opposite side divided by the adjacent side. So that's tangent. Okay, so we'll use m equal to tangent of pi over 6. That goes in for my m. And if you remember tangent of pi over 6, the easiest way, again, for me to remember that as first quadrant values of sine and cosine. So I would remember it as y equals sine of pi over 6, which would be 1/2, divided by cosine of pi over 6, which would be root 3 over 2. And yeah, we have that simplified down. It's 1 over root 3x. Okay, so one more equation. Give us a feel for how these things go. Polar curve is represented by the polar equation r is equal to 2 sine theta. And we want to find a Cartesian equation for the curve and then just describe its graph. We could graph it too. So basic trick, remember that we have to think about r and theta in terms of these two equations. That's how we use our x and y values in order to get our r values. Or excuse me, the other way around, how we use our r and theta values in order to get our x and y values. So we don't see any r squareds in here, nor do we see any tangent of thetas. Okay, at least not yet. So standard trick, make r squared appear. How can I do that? I can multiply both sides by my equation by r. So do r times r and r times 2 sine theta. So that gives me r squared is equal to 2r sine theta. Other trick, remember that tangent of theta isn't the only way to relate theta to the sides of your right triangle. Use other trig functions. For instance, sine of theta is equal to y over r, and cosine of theta is equal to x over r. And you notice right here, we have an r times sine theta. That's actually exactly what we get right here from our sine equation. So think about your other trig functions that you have available and make those substitutions. Okay, so the last thing to do is substitute. R squared becomes x squared plus y squared. X squared plus y squared. And 2r sine theta becomes 2y. Okay, and so we have that guy right there. Hopefully this equation looks like something familiar from pre-calculus algebra. This is an equation of a circle, just a little bit in disguise. The equation for a circle, also, I'll put that over here. X minus its x center, y minus its y center, and the value r squared. Okay, so we can actually turn this guy into a circle. Standard tricks, completing the square, right? If all the y's need to be wrapped up in a square like this, well, that's what we can do with these guys right here. There's a minus 2y if we bring it over there. So how can I complete the square? I think that should be an obvious one, right? We'd actually want a +1, right? Here and here. So we're looking at a y minus 1 quantity squared equal to 1. And that tells us this is a circle of radius. Okay, so the radius over here is whatever you're squaring to get the number there. So there's technically a square value right there. So radius 1 centered at xy equal to, should say xy because you're saying I might thinking about polar coordinates or Cartesian coordinates. You got to be careful now. And the x center is 0 and the y center is 1. Okay.